Welcome to Easy BTech, your guide for BTech and beyond. You can learn the subject very easily. My name is G. Sampath. I am going to explain the subject VLSI. Today, we are going to discuss the topic inverters. So, before going to know the different types of inverter, so what is the inverter? What is the inverter? So, the symbol inverter is this is a circuit symbol inverter. So, let us define what is inverter. Then we can see the different types of inverters. So the inverter. So it is produce, the basic definition, it is produce complete range of complete range of complete range of logic circuit. So what is the work of this inverter in digital circuits, in MOS transistor gates? So it is produce complete range of logic circuit. So it produce it produce it produce fully logic 1 and fully logic 0. It produce output fully logic 1 fully logic 1 and fully logic 0 fully logic 0. So this is a inverter output. So it produces the complete range of logic circuit. In digital circuit, in digital circuits, in inverter, in a inverter means when we give input 0, output is 1. When input is 1, output is 0. So it produces the output is completely logic 1 or completely logic 0. So that is a function of this inverter in digital circuits. And so it is used to it is it is used to restore it is used to restore logic circuit. It is used to restore the logic circuits restore the logic circuits. So like restore the logic circuits like gates are like gates, Nand Gate and NOR gates, Nand Gate and NOR gates, and also and restore the logic in NAND NOR and also in sequential circuits and memory circuits. Memory circuits. So what is this restore logic? What is this restore logic means? So whatever the input, but it gives the standard output logic. Standard output logic. For example, For example, Nand Gate. So Nand Gate is designed by AND Gate and NOT Gate. So when input is both are input is 1, output is AND Gate is 1 and output is 0. So if any irregular input, if any here any irregular input, it may be the logic is reduced. Irregular input means logic reduced. Even logic reduced, output will be a standard. Output is standard. Output is restored. The standard output. Output is standard. So standard output is generated by using this NOT gate in NAND, NOR, and also used in sequential circuits and memory circuits. So inverter is produce a complete range of circuit. So it is fully logic 1 and fully logic 1, fully it output is fully logic 1 and fully logic 0. So in digital circuit, output is logic 0 or logic 1. We are applying logic 0 input, logic 0, logic 1 input. Output is also complement of 0, 1. Complement of 1, it will be 0. So output is complete logic 1 and logic 0. So restore the standard output. If any degrade means any irregular input means any changes, if any signal is degraded over here, but output will get the standard output. Inverter produces a standard output. This one is the purpose of inverter in digital circuit. Let us see the different types of inverters. We have three types: NMOS, CMOS, and Bicmos. Let us say we discuss NMOS inverter. NMOS inverter. Nmos inverter. So by using the circuit here, the circuit representation of NMOS inverter is, by using this NMOS we can design inverter circuit. You can say this is a transistor over here and the below is also one transistor. So both are NMOS transistors. Design inverter by NMOS transistors. You can see the transistors above one is a depletion mode transistor. Already channel established between drain and source. So now see the supply voltage, electrical property, VDD and VSS, and here we are applying a V input voltage, and taken this output voltage across in between VDD to this output and below VDD and above VSS output is taken in between this drain terminal of NMOS enhancement mode transistor, source terminal of depletion mode transistor. Output is taken in between this. Okay. So here depletion mode transistor. This one is a depletion mode transistor. This is a depletion. This is a depletion mode transistor. It is always on transistor. Always channel established. Always depletion. Always on. So this one is a enhancement mode transistor. This is enhancement mode transistor. NMOS enhancement mode transistor. So there is no channel established from drain to source in enhancement mode transistor. Channel established by applying external voltage. Here depletion, no need to apply external voltage, where VGS is equal to 0. VGS is equal to 0 volts. No need to apply external voltage. So gate VGS is equal to 0 and already channel form. There is a current flow through this. Now let us see this. Apply input we can apply input logic 0 and logic 1. So when we are applying logic 0, 0 volts, we are applying 0 volts. So what happens? So this will be no channel existed. So this is like a open circuit. This is like open circuit. Let us see this one. This is a open circuit. When Vin is equal to 0 volts, it is a open circuit. So already channel established. Then output equal to VDD. Output equal to VDD or 5 volts or 5 volts. So it is a complement. You see this one by using this NMOS transistors. So input is equal to 0 volts. This will be off. No channel existed. Then VDD passing through this. There is a current flow this. Then current flow this output is equal to 5 volts. Now second one, if you are applying plus 5 volts, or we can say this is logic 1. So 0 means we can say this is logic 0. Logic 0 means 0 volts. Logic 1 means 5 volts. Logic 1 is applied. What happens? External positive voltage we are applying to NMOS enhancement. There is a channel established. Between drain and source. So path established. Then current flow from VDD to VSS. Directly connected to ground potential. Then output equal to 0. So output equal to 0 volts or logic 0. This is logic 0. Or we can say 5 volts means logic 1. So this is a working of this NMOS inverter. When 0 is applied, this is off, NMOS is off, NMOS enhancement is off, output is VDD or 5 volts, then it is passing through this one, output is 5 volts or logic 1. When input is equal to positive voltage we are applying, then channel establishment, then current directly connect passing through this one, drain to source connected to ground terminal, output voltage 0 volts. It is 0 volts. 0 volts or logic 0. Let us see the conditions here. We can write here the first condition. Let's just see the symbol gate representation. So when Vin is equal to 0 volts, what happens? NMOS enhancement on. NMOS enhancement on. Sorry, NMOS off. NMOS enhancement off. NMOS enhancement off. Depletion always on. So depletion on. You see, depletion on. Now what happens of V out? Output voltage equal to 1. Output voltage equal to 1. Or we can say it is logic 1. We can say, or it will be 5 volts. So this is a first equation or first condition, first representation. Let us take a second one. Input voltage is equal to 1. We are applying logic 1 or plus 5 volts. Logic 1 or plus 5 volts applying. What happens? NMOS enhancement is on. NMOS enhancement is on. Depletion is on. Always on. So depletion on. Then what is the status of the output voltage? Output voltage equal to 0. So 0 volts or logic 0. We can say or logic 0. So this is the representation. When you are applying logic 0, output is 1. Logic 1, output is 0. So this is a circuit representation of a NMOS inverter. It is a basic inverter. So we can design any other inverters like Cmos inverter. And also we can Nand Gate we can represent by using this NOR gate we can represent it. Now next one we can see Cmos inverter. Cmos inverter. By using Cmos inverter, it is a complementary metal oxide semiconductor. So circuit inverter, same gate, but representation transistors are different. Representation transistors are different. You can see the inverter by two transistors are in series. One is above is PMOS, the below is NMOS. Above is PMOS, below is NMOS. You can see this one more. So it is a circuit representation of a inverter, CMOS inverter. You see there is a bubble. So how can you represent this PMOS and NMOS? So PMOS is a bubble across the gate terminal. If there is no bubble, then it is a NMOS transistor. So both are enhancement mode transistor. So V in and output voltage here. Taken output voltage. This is VDD and this is a ground potential VSS. Inverter, when you are giving a logic 0, output is 1. Input is 1, output is 0. That is a simple representation of an inverter. And even though it will be the irregular voltages, but it will give a standard output. That is the purpose of this inverter. Standard logic output will be given. So fully logic 1, fully logic 0. So CMOS inverter. So why we go for the CMOS inverter? Because in NMOS inverter, depletion mode is a load resistance. It acts as a load resistance. So resistance is not designed, not possible in IC design. That's why we use this NMOS transistor, MOS transistor. So depletion mode transistor means it is always on transistor. So depletion mode always on transistor. So there is a constant DC current flow through the constant constant DC flow through the DC flow through the constant DC current. So constant DC current flow through the depletion mode transistor, flow through the drain and source terminal. So even though we are not applying input voltage, there is a constant current flow through the circuit. So it may be causes to heat the circuit. That's why we go for the CMOS inverter, right? CMOS inverter replacing this NMOS depletion mode transistor, and we can place a PMOS. Instead of NMOS depletion, we can place a PMOS transistor. So it is a complement of NMOS. So this is NMOS. We can say this is NMOS and this is a PMOS. Both are complement each. So that's why it is called complementary metal oxide semiconductor transistor. So we discussed in the CMOS fabrication. Okay, so input voltage, the common input voltage we are applying. So in NMOS inverter, we are applying only this NMOS enhancement mode transistor. Depletion mode transistor, we are not applying any input voltage. VGS is equal to 0. Now common voltage input is applied. Output is taken in between the source of PMOS, drain of NMOS. So V output voltage. So generally PMOS when it will be on and when it will be off. PMOS on for logic 0. Off for logic 1. So for logic 1 it will be off. For logic 1 it will be off. For logic 0 it will be on. PMOS condition. Second, NMOS condition. When NMOS will be on, the channel establishment, the device is on in enhancement. So when it will be on for the logic 1 it will be on. When it will be off for logic 0 it will be off. logic 0 it will be off. So we can say logic 1 means it will be plus 5 volts now. Logic 1 means plus 5 volts. So logic 0 means we can say it will be minus 5 volts, negative voltage. So it is logic 0 or 0 volts. We can say minus 5 volts means 0 volts. We can say in a digital. Like when we are applying V in is equal to 0. When you are applying V in is equal to 0 volts. The first condition we are applying 0 volts. So 0 volts means what happens? PMOS will be on. So for 0 PMOS is on. For 0 PMOS is on. NMOS is off. NMOS is off, PMOS is on. So it is disconnected. Then output voltage is equal to VDD or logic 1. So output voltage is equal to logic 1. We can say logic 1. When I am writing 1 means logic 1. Now let us take the second input. Input is equal to 5 volts. 5 volts or logic 1. 5 volts or logic 1. So 5 volts is applied. NMOS is on. So this is on and this is off. This is on, this is off. So there is no VDD and there is no current, there is no VDD through this. So what happens? The voltage, then the IDS through this drain to source voltage directly connected to this. When it will be on, it will be connected to this ground potential. So output voltage equal to 0. So logic 0. So input voltage is equal to logic 1, output voltage is equal to logic 0, input voltage is equal to logic 0, logic 1. So 5 volts means 1, output is 0. It is act as an inverter. So when you are applying 0, it will be 1, it will be 1, output will be 0. So this is a circuit representation, Nmos inverter. Now let us see the current equations. So the below one is called Nmos is called pull down transistor. We call it is pull down transistor, and this is a pull up transistor. This is pull up transistor. This is pull up transistor. The transistor which is connected to VDD is called pull up transistor. The transistor which is connected to VSS, output to VSS, is called pull down transistor. Now let us see the current equations. Let us see the current equations. So we have drain to source current of MOS transistor, NMOS transistor we discussed, that is in beta in saturation region, VGS minus VT whole square by 2. VGS minus VT whole square by 2. This is in saturation region. Saturation region. Saturation region. Okay. Let us take the current equation. Let us take the current equation of PMOS. Drain to source current of PMOS, IDSP. IDSP. So PMOS, this is a PMOS. So drain to source current. Drain to source current. IDSP is equal to, so beta VGS. VGS means how many inputs are there? Vin and VDD. Here two inputs are connected. So one is from VDD, one is from Vin. Now, so we can take this VGS is nothing but a Vin minus VDD minus threshold voltage. VT means threshold voltage of PMOS transistor whole square by 2. So this is a drain to source current of PMOS transistor. So let us take this IDSN, drain to source current of NMOS transistor. Drain to source current of NMOS transistor, we can take this beta into, so where is Vin? Vin in saturation region, it is Vin minus we can take VTN, threshold voltage of NMOS transistor whole square by 2. So these are the two equations. Equation number 1, drain to source current of PMOS transistor, drain to source current of NMOS transistor. Right? If if beta, this is a beta p, we can say this is beta p and this is beta n. If beta p is equal to beta n, so if both transistors are equal, the condition is input voltage is equal to output voltage is equal to, it is 0.5 VDD. When it will be 0.5 VDD, then it is actually inverter. 0 as a input, output will be 1. So if it will be 1, if it is equal to 1, it should be 0.5 VDD. So 0. VDD is equal to 5 volts means 2.5. When it will be 2.5, then it will be equal to the output voltage. Now what happens here? What is beta P? Beta P is nothing but epsilon insulation in IDS versus VDS relation. We discussed this. Epsilon insulation, epsilon naught, W into L, W into L, and we can beta P is nothing but epsilon insulation, epsilon naught, mu into W by L divided by D. Okay, mu P, mobility of PMOS, P-type charge carriers, P diffusion. So W is the width of the polysilicon P-type, length of the channel P-type, and beta N is equal to epsilon insulation, epsilon naught, mu N, W width of the polysilicon, N type, and length of the Nmos N type by D, and W by, so it will be equal, both are equal. So the length and width ratio WP by LP is equal to, WP by LP is equal to, so it is 2.5 times of WN by length of the NMOS transistor. So the condition for a PMOS transistor design width and length is 2.5 times of NMOS transistor. So this is a Cmos inverter current equations and circuit representation, input output voltage we are applying. Now, so it is a low power design. Cmos is a, now let us see the Bicmos inverter. So Bicmos inverter is a designed by bipolar and Cmos transistor. Bipolar, bipolar and Cmos inverter. So Bicmos inverter. Let us see the Bicmos inverter. So it is like a complex design using more number of transistors, CMOS and bipolar transistors. So let us see the circuit. So first one is a CMOS representation. Then it is connected to the bipolar transistor. Then it is connected to the bipolar transistor. You see, this is NMOS. NMOS transistor is connected to this bipolar transistor. Now this is connected to the supply. Then the common input voltage is given. The common input voltage is given, and in between we'll take the output voltage. So across this load capacitance. Now let us see the input terminal, input and output. Let us mention the supply voltage, and this one is a ground. We take the output voltage here. It is a load capacitance. Let us take the bipolar transistor T1 and T2, and this is T3, and this one is a T4, and this one is input voltage we are applying. So Bicmos inverter means the inverter designed by Cmos and bipolar transistors. Here T1, T2 are the bipolar transistors. Cmos, it is a PMOS and NMOS. PMOS and NMOS. So how many transistors are here? Two types of transistors. Two technologies, bipolar technology and CMOS technology. PMOS and NMOS is there, it is a CMOS. Now bipolar transistors. Now what happens here? So let us see the conditions. When Vin is equal to 1, when Vin is equal to Vin is equal, let us say first Vin is equal to 0. Vin is equal to 0, what happens? T4 is 0 means T4 off. T4 off. T4 off, so that the base voltage will be 0. T1 also off. T1 also off. T1 also off. So Vin is equal to 0. What happens? T3 on. T3 is on. Now the voltage, the current through this drain and source will goes to the base of this one. T2. Then T2 is on. Then T2 on. Now the load capacitance. Take this supply voltage VDD through this collector and emitter, then capacitor will be charged. So load capacitance charged, load capacitance charged, load capacitance charged. So up to VDD. So CL charged to up to VDD. Then output voltage equal to 1, or we can say equal to 5 volts. Logic 1 or 5 volts. Now second condition, when Vin is equal to 1, when Vin is equal to 1 or logic 1. So logic 1 we are applying. Now logic 1 we are applying. What happens? Logic 1 we are applying. 1 we are applying, what happens? T4 is on. T4 is on. So that T2 also on. T3 off. T3 off. T2 also off. T2 also off. Capacitor will be discharged. Now what happens? T3 off. Here T3 off. T3 off, so that T2 off. T2 off. Now T4 on. T4 on. T4 on. T1 also on. T1 also on. Then CL discharged. CL discharged through this collector and emitter. CL discharged. CL discharged. Then V out equal to 0. V out equal to 0. V out equal to 0 volts. Now if you are applying 1, output voltage equal to 0. Output voltage equal to 0. If you are applying input is equal to 0, if you are applying input voltage equal to 0, output voltage equal to 1. Output voltage equal to 1. Now what happens here? So the drain terminal of NMOS is connected to this one. The drain terminal of NMOS is connected to the supply voltage. So there is the drawback of the circuit. Drawback of the circuit. Drawback of circuit. Constant DC. Constant DC current. Constant DC current from VDD to VSS. VDD to VSS through the transistors. Through the transistors. What is this? T4 to T1. So here this constant current flows through this one, through ground potential. T4 to T1. So it may be affect the circuit. It may affect the circuit conduction. It may affect the circuit conduction. Affect circuit conduction. Circuit conduction. So then rearranging the circuit, then rearrange the circuit, rearrange the circuit, rearrange the circuit. So rearrange the circuit, it will become like removal of that one. You can say this is a PMOS transistor. So this is very important. I think 2 years back asked this question. Explain the working principle of Bicmos inverter. Working principle of Bicmos inverter is asked ma. So try to note down this and you can practice. Okay. So you can alternative circuits also you can draw and explain. You can draw the circuit and explain what happens. Why this removal of this drain to source terminal and placed in between these transistors, bipolar transistors, placed in between these bipolar transistors. You see this one and ground and a capacitor, load capacitor. Okay, let us see this input and output. Input, and this one is output voltage. Output voltage transistor T1, transistor T2, and VDD. This is a PMOS transistor and T3, T4, T3, T4. Now removal of this drain terminal, there is a constant DC current from VDD to ground potential, VDD to ground potential through these T4 and T1 transistors. Now removal of that one and placed in between these T1, T2 transistors. Okay, then by rearranging circuit, DC path removed. Again there is a problem in that after designing that DC path, after removal of that DC path removed, rearranging the circuit, DC path removed, DC path removed, DC path removed. So but what happens, but output voltage, Vout voltage, Vout voltage, Vout voltage is added base voltage. Vout voltage not reduced, not not reduced base voltage, not reduced base voltage. Now what happens here? So Vout voltage is equal to base voltage 0.7 plus saturation voltage 0.1 volt. So total it will be 0.8 volt. So inverter is nothing but a fully 0 or fully 1. So it is not fully 0. When it will be discharging, it will not fully 0. Okay, then we can again change the circuit. Again rearrange the circuit again. Rearrange the circuit again. Rearrange the circuit again. Rearrange the circuit again, but load capacitance. So what happened? This path is removed. This path is removed from here to here and placed over here. Then what happens here? The capacitor is discharging when V in is equal to 1. V in is equal to 1. This one will be on. This one will be on. And this one will be off. And this is off. Now capacitor is discharging. capacitor is discharging through this. What happens here? Here the base emitter voltage will be added, and collector emitter saturation voltage is also added. So total output voltage is 0.8 volts. So it is an inverter. Inverter means it is fully on or fully off. Means fully logic 1 or fully logic 0. It is not comes under the fully logic 0. Then we can again rearranging the circuit by placing a resistance path over here. By resistance path over here, we can see this one. This is a bipolar transistor. Now there is a path in this problem. In this, we have taken a resistance over here and placed it in between this and the bipolar transistor T1 and T2. And here one more resistance path is placed here. One more resistance path placed here. Now input voltage, let us take the input terminals. This is V in and this is V out over here, so this is a V out. So we have capacitance, load capacitance, T1, T2, T3, and this one is T4, resistance R1 and resistance R2. So the problem is when it is discharging, the discharging path through this one, then base emitter voltage also added. Base emitter voltage, cut-in voltage 0.7, and saturation voltage, collector to emitter saturation 0.1 voltage. Total is 0.7. So by rearranging from the previous circuit, we added resistance R1 and R2. So there is no current flow to this R1. Then what happens? The load capacitance discharged through collector to emitter. Then it will be reduced to so only saturation voltage 0.1 volt. 0.1 volt is reduced. So what happens after rearranging this? Resistance designing is difficult in a MOS transistor. Resistance design difficult. Resistance drawback in that previous circuit. Resistance, even though reducing the output voltage to 0.8 to 0.1, resistance design difficult in MOS transistor. MOS transistor. So the final arranging circuit. So final rearranging the circuit. Final rearrange the circuit. Final rearrange the circuit. Let us see this one. Instead of resistance, we are added the NMOS transistors. Let us see the Bicmos circuit having a PMOS transistor and bipolar transistors here. Bipolar transistors here. You can say this is a bipolar transistor. Now here one NMOS transistor is added. And also the transistor T4 from here. It is placed over here. Now the bipolar transistor over here, and from here it will take an output Now this is connected to ground, and we have load capacitance, load capacitance, and one more transistor here, reducing the base voltage. Now we can take the input terminals. So this is V in. Now bubble across is a PMOS transistor T3. This is T4 NMOS transistor T2 and T1. Load capacitance, output voltage of a inverter. Now this one is T5 and T6. T5 and T6. So when V in is equal to 1, V in is equal to 1, what happens? T3 will be off. T3 will be off. So that T2 also off. T2 also off. Now T5 is on. T5 is on. T4 is also on. T4 is also on. Now capacitor is discharged. So from there is no supply goes to this capacitor. Capacitor is discharging through this collector and emitter terminal. Collector and emitter terminal. So whenever this will be on, then the drain to source voltage goes to this base of this T6 transistor. Then when T4 is on, this voltage will through this drain to source, it will be connected to ground potential. So there is no base voltage. So there is no base voltage. There is no base voltage to this bipolar transistor. So base emitter voltage less than 0.7. Then the capacitor discharged through this collector and emitter. So the output voltage is equal to 0.1 volt only. So 0.1 volt. Output is 0.1 volt only. 0.1 volt only. So it is fully 0 when it will be 1. When it will be 1, it is fully 0. So this is a rearranging and alternative circuits of Bicmos, and we have seen Cmos inverter and Nmos inverter. So please subscribe the channel and like and share with your friends. Thank you.